last thing we covered in the class were homework 3, problem number 5.
Yes.
Right?
Yeah.
When we did match general solution to specific boundary condition and therefore generated what? Last camera. What did we generate as an outcome for the problem number 5? Let's look what Melody did. Oh, okay, I see some errors by the way, but okay, then it is good. Then it is personal and individual work. So
Protocol for A, B, alpha, and beta, right?
yes.
I don't know where my lab.
And what did you notice by looking on the answer key or on the solutions? On the solutions for the problem 5.
3 of them were 0.
Yeah. 2 of them were 0. But yeah, I'm going to stage and do an interview because otherwise we will fall asleep and the So to surprise.
Oh, we're gonna get surprised. I don't like.
So Patricia, may I ask you how many solutions Schrodinger equation typically has?
A lot.
Okay, excellent, thank you. Did you hear it? Okay. How many solutions did we get in the problem 5 in the homework 3?
4.
Or 8 because it was like 0.
Because it was like 0 and all real numbers for some of them.
Yeah, some of them was like 0 and another number.
Okay, you will vote what is
Oh,
how problem number 5. You have it in front of you, right?
yeah.
How many answers?
4, right? Or 8.
No. How many unique answers? How many values of the parameter alpha?
Of parameter alpha? 1.
What?
Well, if it's all real numbers, then it's infinite, but yeah, I don't think that was in the answer.
Okay.
Sorry, we're choking.
I don't look at the answer.
Do you find the solution you are looking at corresponding to the answer key? Yes, it does. So I'm just reading through. So A equals, can you just read and explain what is here?
Well, one answer is A equals 0. That's probably for one of the initial conditions if it's of 0.
Next one.
And then also
A. This one or capital A?
Lower.
And then.
like pi times any real numbers.
So if the answer is pi times n, how many solutions does it represent?
Infinite solutions.
Yes, I'm so happy to hear it. Everyone.
Yeah.
Do you agree?
Yes.
Okay. Who disagree with who wants to disagree? Oh, okay. Okay, good. So let's check those who are online. So
Sam, MIA.
well, we do see
We get an
oh, here is Sam.
intimate.
So Sam and Melody, we just discussed in class how many solutions problem 5 in homework 3 has. Can you confirm your point of view?
Infinitesimal.
No, infinite and infinitesimal is different. Infinitesimal is 1 divided by infinite.
I did not know that. I did not know that actually.
No, you do. So infinitesimal means small, infinite means large.
Infant. Then.
Okay, good. So I am going to draw something on the board, but it will be not a surprise. You have already seen it.
Yeah.
Can you put the mic on?
With great pleasure. I think it was a funny thing that happened in this class when I was mumbling something, and then I don't remember who was it. Raised the hand, told like, "I don't understand you. Put mic on." And then I put microphone. I still don't understand you. Oh, no, it was Patricia, and it is why she decided to take rotation. So you see this thing on behind me, right?
Yes.
Okay. And what is the answer for alpha? I just didn't want to have microphone because it may create the feedback through the. Ooh.
Don't do that.
Melody requested it.
You can see how hard you can get it.
No.
So any integer n, right?
Yes.
Now, can we visualize it? Can we interpret it? I do not know which words to use. I will try my best.
Okay.
Oh, thank you.
Figure it out.
You're so generous. But it is an important concept that we need we all need to accumulate, and there will be no way to check it on the exam. It will be only consequences later. It's like fundamental thing that is even hard to express by words or by mathematical formulas, but I'll try to communicate. So prepare for something not very complicated, but unusual. It's a little bit of out of box thinking. And in simple words, we need to admit the fact that there are equations that have more than one solution.
Yeah.
Okay, but we need to admit it really inside our hearts, not just as a, oh, okay, infinite, infinitesimal, whatever. So why we do not have any of the alpha? Like, is it you commanding me to speed up?
No, I'm sorry.
Or like on the stage in the pop music, like. So why we do not have any real number? Why we have a restriction? So if we have a line of possible values of alpha, right? Only certain when alpha equals like minus pi, 0, plus pi, plus 2 pi, right? Only certain values will give us to solution, and all others will not match our boundary conditions. So do you have any comments or suggestions or vision? Is it normal? Is it strange?
It seems normal for like a trig equation,
For which?
like a trig, any kind of trig equation. I said it seems normal if there's like a sine or cosine or something with trig in it, because there's like repeating times where sine is 0 in this case. So if the alpha is pi times n, then anytime n is like a whole number, whether that's positive or negative, the sign is gonna be 0.
Okay, yeah, I like to hear it. So let's, anyone who wants to criticize Eva? No one yet. So here is a little silly analogy, and I will try to give it again and again later in the course. How do you like speed limits on the highways?
I don't, I want to go as fast as I can.
My brother thinks that the speed limits are the slowest that you can go.
Okay.
He's learning to drive, which is considerable.
Like highway 94 is not the speed limit, it's just the number.
That's kind of true, though. The speed limit's only 75, but there's people that are
People are
flying down
going
that,
in
that
easy
freeway.
90, yeah, easy 90.
Okay,
They're making it to the Twin Cities in 3 hours.
But legally, the fastest you can go is the speed limit.
okay. So what is the mathematical description of the possible values of the speed? Like which type of numbers are they?
From like 0 to infinity, I guess. But
It's speed.
But do you get like +1 mile, +5 mile, or they can be 1.5 or 1.7 or like 20?
Oh, it can be in between. You can have a speed that's not a whole number.
Okay. Did you all hear and you all agree? Yes. So this is an important notice or discovery. So we are going slowly through simple things, but it's better to develop this common understanding.
Yeah.
So when we speak about our real life, and also in the quantum case of free particle, any velocity is allowed. Well, below speed limit, if we are talking to police, but formally any, right? This value of alpha is related to velocity, to momentum. We'll show it later on.
Okay.
And the fact that only integer numbers mean it in real life, it would correspond to the fact that our cars can travel only like 10 miles per hour, 20 miles per hour, and cannot, just physically cannot go fractional. You understand? So only discrete values of the velocity. So it is very strange. And it is major principle of quantum theory that we are going to admit and play with again and again. And this is the simplest example where we can, through this trig functions, to discover it by our own hands. And this is why Schrödinger equation has multiple solutions, right? Now, how to interpret, how to visualize the fact that there are only certain values of period or certain values of momentum which are allowed to be legitimate solutions. Again, I don't have good words. I'll just try to speak from the heart. It's typically skipped in any courses and in any discussions, but I think it is a core part. So what if I do have this x, right? 0, L, and here on the y-axis, I will just show psi out of x, right? So if I change the parameter alpha continuously, what would it correspond to? If I neglect our discovery that alpha takes only discrete values, from like multiples of pi, what if I admit any number of alpha, real numbers, fractional numbers? How the wave function would look like? So since we already neglected b, they all will cross 0, right? And then there will be oscillations that will have certain period, right? So we can imagine, and again, you see there are difficulties to explain, and it is not language, it is just concepts. There are two types of infinities, two types of infinities, countable and uncountable. If it is integer numbers, if it is number of apples, even if you have infinite number of apples, potentially we can count them. But if it is continuous thing, if it is distance from the origin on some axis, we cannot tell how many points are from beginning to the end. If we can put so many grid points and then put one more. So there are two infinities, countable and uncountable. And our answer tells that number of solution is infinite but countable, right? We can index and it goes discrete. But if we do not apply this restriction, then we can draw the oscillatory functions with any possible period, and their number is uncountable. Okay. So now the question is, how do we parse? How do we extract? How do we select only those of these oscillatory functions that would match our initial conditions, not mathematically, but intuitively? So I'm going to walk around with an interview, but before I'm going to redraw this figure in a little better case, better way. So 1, 2, and 3. So I did draw 3 sinusoidal lines. They all are sinusoidal, right? They all match this kind of function. But only one out of these 3 will cross the point x equals L. So what is, how do we parse? What is different between them?
Alpha.
Yes, but let's go through a little interview. Patricia, just try. What do you see? What do you think?
What's different between 3 lines? Is that what you asked?
Yes.
The alpha is one of them is a whole number, and the others are not.
Okay, good. Yeah, thank you. Fred, do you want to add anything else? Share what you're thinking. Like, just suffer for another hour, and I can go to the supper.
I mean, like the waves have different, frequencies and wavelengths, obviously, but the ones with the higher frequency and the shorter wavelengths, like, I don't know, like the blue is like in the middle, obviously, I guess, but
Okay, good.
isn't that determined by alpha,
Okay,
like in
good.
sine alpha x, like that number determines like the width
Okay. Yeah,
frequency? Yeah.
Okay, yeah, I admit everything. Eva? Like, what is the criterion? If I have these 3 lines, how do I select one?
Shut up, Fred.
It's
How do
recorded.
we, that's okay. How do we select the blue one?
Yes.
Well, if we know like the value is L on the horizontal axis, then whatever we can put in for alpha or X to spit out L at that value. So that psi is 0 at the value of L.
Okay, okay, yeah, very good. Any additional comments?
Not very many. But when you have to know the value of alpha to be able to find
Mhm.
where, like, to be able to pick out the blue line, because then you have to know at least one of the values. You can't have two variables that you have to solve for.
Okay,
Just need to find the alpha.
okay, yes, and you already know the answer, but we need to not only know it,
We
but
still omitting the like the right hand part? of
Yeah,
that?
are we ignoring the B?
Yeah.
oh yes, we do.
Okay, yeah, so the big A doesn't.
And we do,
Just
right?
lists the amplitude of it.
Yeah, we can even neglect big A or tell that it is one of the big A is the same, 1 over square root of L. So it doesn't affect values of alpha. So maybe I do not know, maybe I'm wrong. I'm just inviting you to think and speak together. And I didn't interview Melody and Sam, but I'll ask you in the next round to speak up about these things. So we can evaluate the value of this function, trial function phi prime at x equals L, and subtract it from 0, which is our target value, and then check if their difference is bigger or smaller than some tolerance limit. Like if you are speaking more
Smaller than what?
tolerance limit, like when you were taking like calculus 1, there were theorems like for any epsilon there is a function with the series will be smaller than epsilon, right? So we need to find such alpha for which phi specified by alpha of L minus 0, which our boundary condition, will be smaller by absolute value smaller than epsilon. Okay, so we can generate all possible functions phi sub alpha, and then parse out of them only those that will match this condition. And then instead of uncountable infinity, we will get a countable infinity. Okay, so what do we do next? I invite you to run the code. I will run it and project to the screen. We look what it makes, then probably follow the success of previous meeting. Just write comments to each line, and then you send reports with figures, comments, and commented codes. Would you approve? Is it okay or too boring? Let me focus camera on you and see how enthusiastic you are. Do you approve? Yeah, because what I saw and heard was this way. Here. Do you approve? Okay. Next time I need to bring coffee for everyone. In 2 weeks, next week I'm not here and I don't know what Dr. Han will do, but there will be lab, but not with me.
Okay.
And in 2 weeks we'll see each other again.
Who will we see?
Huh?
We see.
In the lab, Dr. Yulun Han, my postdoc, for sure. And during classes on Monday and Wednesday, we didn't decide either Dr. Yulun Han or your favorite TA, David Graupner.
Okay.
I love that that's its title.
Okay.
I call all the TAs that we can present him.
So sharing screen,
Well, especially because David and
going
John
to
are
MATLAB,
John. I know, like.
and
That's middle name is John, with an H or no? Jonathan. This is full name Jonathan.
okay.
Johnny. If his name was Jonathan, I would have said Jonathan.
His name is Jonathan.
So
Like
I'm going to clear everything, erase all figures and launch this homework 3 problem 5. I think it is quite boring. Maybe. Do you see the image well? Okay. Now Sam is looks without enthusiasm, as it is boring. Let's invite Elsa to the stage.
You want to try and figure out what's going on with my MATLAB then while I'm on this?
Yes.
It's freaking out and I don't know what it's doing.
So just make yourself comfortable.
Okay.
You'll focus camera on you. I know you like it.
No.
No. Okay, just hit enter once. Okay, and report what you see. And what do you see? What do you see on the screen?
Well, we see two answers. We see 0 and 0.12.
Okay, you all guys are much smarter than myself, and you are more algebraic. Some people are more visual. What do you see on the graphical? Like, explain what you see on this image.
Where is this?
This camera is not recorded.
You open the
Oh,
file that
no.
you sent,
There you go.
like the most recent one.
So what do you see? How do you interpret what is shown on this image?
You have to save it as a file,
I think it's in.
keep it slightly updated.
But let's do like in a kindergarten. How many lines do you see?
Two
Yeah, save it.
lines.
Yes. So do you see anything yellow?
Yeah, and yellow dotted lines. Are just.
Okay, what are red lines?
Or like the, not boundaries, what are they called?
Tolerance?
Tolerance, you said?
I did.
Yeah, what's the, it'll come to me. I can't think of it right now.
Okay. So
One thing in it, hold on.
well, okay, I would call it tolerance. Like the boundaries are on X from 0 to 1. So we are looking only the box, right?
Oh, yeah.
Okay, and then we have yellow lines that sometimes can stay yellow or become black. Hit space or enter once again. And maybe let's look here,
Like the one that you put.
and then look in the figure what happens.
The spiral.
Oh, the yellow line changed. Oh, there's another yellow line.
Okay. Where this yellow line is coming, is appearing.
Above the increasing black line.
Okay, so first yellow line was yellow, but also with black highlight. But the next yellow doesn't fit into this space between red lines. Therefore, it stays yellow.
No.
Okay. Okay, keep hitting enter.
Go to the command window and type that.
And explain what you see.
Yeah.
Oh, even more yellow lines
Do
that are
they fit-
above the,
Do they fit between red
no.
and they stay yellow?
Yep.
Okay, hit a few more times.
Oh, thanks.
A
Yeah.
whole bunch. Oh, they're curving now though.
Okay, they're curving. Okay, good. Keep hitting
I'm
enter.
excited for your presentation.
It's gonna be something.
Curving more, but still all yellow.
But they're like twisted.
Okay, yeah, keep hitting. Bless you. Gesundheit.
Wyatt says that every time someone sees.
Okay. Now I barely can see the lines.
Yes.
Sam, you should run the code yourself and then you'll see. By the way, we can modify the code and change yellow to green, then it will be much more beautiful. And later, let's complete this little exercise. hitting enter a few more times. Yeah, explain it.
Lines,
So how-
more,
why they are,
negatively quadratic black lines. It's the one, Sam, it's the one that he sent in the email. The most recent,
some, okay,
the most recent email. Just double click it, it'll open it into MATLAB. Yeah, well, you better check your email then.
okay, so the yellow line starts to curve and their far side
Oh, but now they're within
Fits-
the red lines.
fits the space between the red lines.
Yeah.
And then it is highlighted by black. I think enough. Let's give let's invite Eva.
Ava's turn.
Thank you.
Thank you. Oh. My turn.
You got it. Well, all you have to do is hit enter.
It's so hard for him.
Oh, yeah, it's so hard. So tell what maybe you already did this exercise on your stage,
Oh,
but,
I
but
definitely did.
explain what
Oh,
you
yeah.
see and what you expect to see.
What I see and what I expect to see.
Black lines are within the bounds from 0 to 1, and so they show up as black.
I guess I don't really know what I'm expecting.
No,
to
the
see.
yellow-
But how do you connect it? You know, let's say-
but the yellow ones are outside of the bounds from 0 to 1, because they, like, their end.
Well, I mean, if the trend of the yellow, or I guess the yellow combined with the black curved lines that are happening looks like starting to form like a sine curve.
Yes, but which of the lines become black and which stay yellow? What is the criteria? Can you say that this far edge must fit the space between red lines?
Yeah,
Okay, so if you keep, we see that this curved thing becomes more and more curved. Likely it is a sinusoidal that will go up and down. So when do you expect to see another set of black lines and what they should look like?
yeah, they'll probably be in just more black lines that fill in the area between the two red
But
lines.
how many minimum, maxima inflection points? Like what this one like a half period of sinusoidal. What will be the next one? That's my.
What? This is a half, yeah, a half.
So what will be the next set of black lines?
The second half.
Okay, let's try. Hit the enter a couple of times and see what happens. So they
Is it
appear here
happening?
below and it curves.
Oh,
more.
yeah,
Yeah, keep hitting,
okay.
keep hitting. So they kind of cover the space with yellow.
Yeah,
Keep hitting, keep hitting. And now they're coming up and down and then back up, right?
yeah.
Keep hitting. Oh, yeah.
Oh boy.
So explain what you see.
Oh, so now it's the full sine curve rather than just the half, the first half.
Okay, so first, when we had a straight line, it was pi n equals 0. This one was pi n for n equals 1. What n equals to in this case?
1/2.
It's the higher the frequency, more fringes we see.
So 2. And
Yes.
there's 2.
Yes, perfect.
Okay.
Yeah, thank you. Okay, now it's turn of Fred. Please join me in welcoming our next speaker.
Good echoes in there.
The best echo would be putting microphone to the
Yeah, true.
Can I
So-
press the,
just what do you see and what do you expect to happen next?
well, it's one, like complete oscillation, right, of the
Okay.
sine wave. I think that it'll continue to, it'll like go up and again, probably come back down to 0.
Okay,
as we continue to like fill the space with more lines.
okay.
Yeah.
So when this edge at position one will fit into this space between the red ones again, it will become black again.
Yes.
Okay, please
All
try.
right.
Denser and denser fringes. And
Oh.
yes. Okay, so
All right.
how do you interpret it? Alpha equals pi n. What n equals to here? I'll tell you how
no
to count.
idea.
You count how many maxima or minima. Like for the first, there was only one maximum. For the second was one maximum, one minimum. Here we have
3.
yes, exactly 3.
That's
You're done.
the value of alpha.
Alpha divided by pi will be 3,
Okay.
and alpha times pi times n times 3.
Okay.
Okay,
Yeah.
make sense?
All
Okay. Patricia, I apologize. The code stops here, but you've got the idea. Okay. So let me.
All weekend.
Yeah. There was a question.
Boundaries are within 0 to 1. The others yellow line I can see are the they are not the permissible ones like this. They're not the permissible ones because the nose shows like from here, the black one, it shows from 1, it shows 2, it shows 3. But the yellow ones, what do they mean? The yellow.
So thank you, Patricia. There was a question. If we are interested about particle in the box, why do we have non-zero values of yellow line outside of the box? And the things outside of the box are not our business. They do not apply. We know we will prove in the lecture that wave functions there will be absolute 0. Mathematically, the sine sinusoidal function is defined everywhere, but we care only about the value of sinusoidal function between borders, because we already discussed in class, electron wants to stay on the molecule. It will have 0 probability to be outside of the molecule. Make sense? Yep. Thank you for supporting. Sam and Melody, do you want to ask any questions or complaints about this little image?
I have some complaints.
How about Sam?
Oh,
I would just like to say that I'm a genius and I changed the color to green.
yes, let me stop sharing and let you share it so that we will enjoy it together.
I changed to my tablet because I can't run Zoom and MATLAB on my computer, but I can turn my camera on and show you.
Okay, yeah, please do.
Okay. Okay, can you see my computer?
Just a second. Yes, I can, but I want to project it to the bigger screen so that everyone can see it. And I think one needs to just double click. No? Okay. Do we all see it? So green is more beautiful. Okay. Yeah, thank you, Melody.
No problem.
Okay, that's great. That's great. Yeah. So
I need you to let in my other computer, the one that I run MATLAB on, because I don't have it on my desktop still.
Sam, your computer with MATLAB is with you or it is in the different city?
It's in front of me, but it's waiting to I've been waiting to get let into the meeting on it.
Okay, but yeah, run MATLAB there and also launch meeting. So when it will be your turn to share screen, you will be ready.
Well, I'm on my computer right now, but it's waiting in the waiting room. Oh wait, I'm in the wrong. Nope, I opened up the wrong meeting apparently. Give me a sec. I have no idea where the heck. I don't know which Zoom I have been using. This is what? Here we go. I found it. Not me totally just sitting in the lecture Zoom for the longest time.
Admit.
Give me so smart. So bright young fellow.
Okay. If you want to share something, please go ahead.
Yes.
I'll stop sharing and then.
This is what I've got. Just a nice solid looking. I kind of just like held down the space bar or the enter bar on it.
Do you want to add anything to interpretation, like how we already discussed it, but try your own words. What do you see here?
I'm gonna be honest. At the curve, like down here, at -0.2, it just like gets really like clumped together. And then it kind of spreads out the farther down the x-axis you go. So I don't really know how to interpret that, but just kind of like an observation.
So let me help, but we will try and interpretation and explain. Yeah, would you please keep it on the screen?
Yeah, sorry, I'm trying to like get it so that I can just have MATLAB as
okay. So in your homework and in the class, we are looking for solutions of particle in the box, right?
Yes.
And we know that there should be several. So we are, the yellow lines are any possible real values of alpha, and black lines correspond to only favorite, best values of alpha that match boundary conditions.
Okay.
Does it agree with your vision?
What do you mean by vision? In terms of like
of this figure.
Oh, I would say that like if the black lines are like your ideal points for alpha and the yellow are all possible, I feel like you know, as you go farther and farther, you have a less likely chance to actually be getting an alpha that is like ideal for like what you're trying to find compared to like closer to your like origin.
Okay, yeah, sounds really great. Okay, yeah, thank you, Sam. You can stop sharing.
Yes.
I will start sharing. And what happens if I continue to pushing hitting enter?
And what is the?
So I think it will end at some point. The code doesn't show.
Yeah.
So the answers show the value of alpha, first number.
Yes.
And the second number is the subtraction, the criterion, whether it falls between red lines, right? So if the second number is big, then the line is yellow. If it becomes small, then it becomes black. So here is one more line, which is it shows like this little oscillations. So the blue line here comes a little higher than the red line and then comes back. So when it is exactly our criterion parameter. When it is below red line, below red criterion, the yellow wave function become black wave function, and we see 0, 1, 0, pi, 2 pi, and 3 pi. The next line shows 1 divided by criterion. So when criterion becomes very close to 0, 1 divided by this criterion becomes close to infinity. And the x-axis shows not the alpha, but alpha divided by p. And we clearly see there are strong peaks at 0, 1, 2, and 3, right? So this is the answer that you got in your homework, right? But now I don't know was it a waste of time or you get a little more feeling of what it is through your hearts, right? So it is not just a number, it is a parsing, selecting the preferred wave functions out of all possible wave functions. Okay, so I suggest we just open the script and go line by line and write comments, same as we did last time. Is okay? We will swap shares in this front seat.
Yeah.
And at the end of the meeting, you please send the version of code with comments and your screenshots of most representative figures with very brief comments, same as you do in other labs. Okay. So I'll start just to break the ice, and then probably we'll go through Patricia, Melody, Sam, and then Elsa, Eva, and Fred, right? So the whole code is about 60 lines, so about 10 lines per person. Oh, maybe less. I take a couple of them. So hold off. What does it mean? Replace figures. Create an empty variable. Create an empty array. Square root of -1. What is it?
I.
And what is I? Yeah, imaginary unit. Imaginary unit. L equals 1. Just to make life simpler, it is the size of the box. Size of the box. X max. We just define the independent variable in the space a little broader than the size of the box. Define independent variable in a broader range. What is dx? Step size. Step. We represent continuous independent variable by discrete grid points. So infinitesimal step to represent independent variable. Independent variable. X, it was unsuccessful. It is just very broad, very not used, very broadly defined independent variable. Independent variable. No, maybe it is used. The XX is, I would say, narrowly defined independent variable that will be used for voting inside the box. Black. Sigma, I don't know what is it. No idea. Tolerance. I'm too active. I should give you guys a chance to type something. So Patricia, would you please go to the stage and type something on this computer? Come on in.
I'll do it through it. We'll do it.
We'll do together. And while you're typing on this computer, I'll type on yours so that your life will be simpler. So which line are we speaking about? Line 10, tolerance, it's enough. It's a tolerance limit. If one runs it over again, one can use a smaller value. So what is FF? Maybe it's like a trivial function of the trivial solution. Function equals to 0 in the area of definition. So wave function that is equal to 0 everywhere. Wave function that is equal to 0 everywhere. By the way, if it is 0, then it is non-normalizable, and then it will be not contributing to actual solutions. Now, K max equals 12. I believe this is a range of the alpha parameter. It will increase up to this value. So instead of going to infinity, we just scan several. Grid equals 100. It's just number of grid points. Number of grid points for representing alpha, comma, wave frequency of the wave. Representing frequency of the wave. Okay. D K max over grid. So increment of frequency of the wave.
Frequency of the wave.
Of the wave, yes. Okay. I think it is enough. Yeah, thank you, Patricia. No. Before we swap seats, please make sure that all comments you typed will be green. So before you start comment, there should be a % sign. So the meaning is that, percent. Change keyboard. I think you click to foreign keyboard. Let's click on the top. Here, click to US, and now put before range. So if you do not have this %, MATLAB will try to run.
Yeah.
Okay, excellent. Thank you so much. Okay, Sam, would you like to be next? Okay. I think you should request control over my screen and you will type right here. Can you do it? Like on the top in Zoom parameters, you can click request screen control, and then you can do anything on my computer, use my credit cards, put A grades to everyone in the class. Did you found how to do it?
Don't
an
tempt
important
me with
skill,
a
you need to find
good time. Let's see here. I breakout rooms requirements. You said upper left.
Okay, let's do otherwise. I'll try requesting control of your screen, and then after you see it is possible, we'll swap once again. So I stop sharing. Now please share your screen.
Okay. Sharing my screen.
And now those who are in the class C, there are near the green thing on the top, there are view options. And when I click to the view options, you see it, right? Oh, no, you don't. Near the green thing, there is a view option, and then one shows request remote control, not screen, request remote control. Before I click it, would you like to make a little visit and watch it? Who is interested? Just look on it, because we will need to do it in the future to control screens of each other. So you are viewing Sam's screen and request remote control. Okay, at least one class attendee saw it. Yeah, thank you. So if anyone wants to control my computer, Eva will be a delegate. So request remote control of Sam's screen. And then Sam, on your side, there should be something. Yes, and it tells me click to start the remote control of the screen. And now I can do I can do
You can figure this.
like DK, I can type increment of frequency of the wave. Okay, now I'm give up, stop remote control. Sam, you please stop sharing. Now it's like a little game. I start sharing, and you can request remote control. So on the top, near the green thing. Okay, Sam is requesting remote control of your screen. Approve.
I can control the screen now.
Yes.
What? Let me see here.
Please be kind and do things only related to the class. Do not assign all A grades to the class right now. Although you have power to do it.
It says that I have your.
You double click and then you can move mouse and type things.
Oh, okay. Okay, I see. I thought that it would here. Let me see if I can get this.
My screen is your screen.
Perfect. Full screen. Here we go. That makes life easy. Cool. Don't worry. I'll make sure to not steal too much of your banking information. All right. Huh?
You're being recorded.
It was a joke. All right. What do you?
Okay, so what is n equals from 0 to grids? How would you interpret it?
I would interpret that kind of as, when I think of grids, I kind of think of just like increment points of on like an axis.
Okay, then type it as you define it. And this variable n is discrete, but variable k, in our class it was alpha, but n times dk.
So n times the derivative of k?
Not derivative,
or
times
not derivative.
increment in space. So it will be continuous change of the frequency.
I have to make sure I don't mess up my
Yeah, great. Great.
writing because I can't. Oh no.
That's fine. That's
It's
fine.
delayed.
So line 22. Well, I think it is not a plane wave. It's just a sinusoidal wave of frequency k, right? Just wave.
Okay.
Sinusoidal wave of frequency k.
I think that's how you spell that. Sinusoidal. That does not look right, but whatever.
Sinusoidal wave of frequency k, if you want to. Now the line 23 is, since it has percent, it means it is not counted. Next one, 24. So we just take absolute value of this sinusoidal, because sometimes it is positive, sometimes it is negative, but we want to make it is a criterion that needs to be small enough. Okay, what is on the next line?
It's a good, very good question. I don't like how delayed this is. It bugs me. Here we go.
Let's chop it on two lines, or not necessarily. Just do what you did. Let me do something quickly. So you're tired because of me, because of class, or just a long day?
Today.
I'm just tired because I had to do a nice solid like 100-meter sprint, and then I ate the ground.
Okay.
It's not fun.
So we chopped this line onto two. So in line 25, what do we plot?
Our X are 5K, and then
What is the color of this line? What is letter Y stands?
purple.
Huh?
The Y yellow. Yellow.
Yes.
Okay.
Like plot yellow wave. Plot a yellow wave of arbitrary frequency. Okay. Of the frequency K.
Okay.
Okay. What is hold on?
Hold on.
Definitely better than shut up.
Just hold on.
Yeah. Hold on. What does it mean?
Still waiting for humans.
What is a command? MATLAB command. What does it mean?
Wait a minute.
Does this? In fact, you remember yellow lines were occupying all space. They were not erased at each new iteration.
The hold on, would that be like you have to like initiate it coming again, like go like running again?
Right. It means keep the old drawing and accumulate new drawing on the top of it. Okay. Yep. Yeah, cool enough.
Or sorry, I guess.
Okay.
Enter to make new drawing.
Okay. Now I'm going to chop this onto
Melody.
melody.
Oh, I thought you said you were gonna
Maybe,
like chop it
Sam,
so that melody.
yeah. Let's go to melody. Otherwise, there will be no. We all need to do. Yes. So Sam, please. Oh, you just stop. How to say?
The screen
No,
share. The control. I gave you back
Yes.
control.
Abandon, decline. What's the right word?
You can stop.
Oh, I can stop Sam.
Yeah.
Really?
No one can stop me.
No one can stop Sam.
It was like up above though.
Melody Johnson requesting remote control of your screen. Yes. Okay. Now it's turn of Melody. Melody, would you please go ahead and type? And also explain what do you mean by typing this and that.
I don't know if it's working.
You need to, I did accept, you need to double click and then you can start typing. Melody Johnson is
okay.
controlling your screen.
Okay.
I do see it. Yes. Just keep typing, it will move.
Okay.
So what?
Okay, so this is the red lines.
Yes, plot red lines. I think it is a good enough. Plot red lines, which mean tolerance limits. Or in the bracket, red lines, brackets, tolerance. Hold on,
Oh my goodness.
just
My computer is slow.
that's okay. Tolerance, okay. Yep, that's great. So hold on is, yeah, keep drawings. It's shorter than the sentence about spam. Okay, so next line 31. So we just checking if the boundary condition was met, if the arbitrary line is close to 0 at the boundary. Okay, yeah, good. And this if goes as low until maybe I just move the mouse for a second and then you control back. So this if command goes until the end. So everything that goes until the end belongs to this condition. So it's conditional operation. So line 32 is skipped because it is already 100%, and for line 33 it is so we assign to this variable a good sinusoidal function with a good frequency that did match boundary conditions. Okay, to this variable. Okay, next line. Which color this plotting is using?
Black.
Yes, K means black. Do not ask me why. I don't know. Anyway. So we are plotting good black line. That matches boundary condition. Okay. That's great. That's really great. Okay, Melody, I think we need to give a little of chances to exercise to the rest of the class. So if you don't mind, you can, oh yeah. So.
Suppose.
Would you like camera focused on you or not focused? Okay, then I humbly focus it on your seat, which I will take. I know it is not humble, but I like camera focus. Okay, so which line are we working on? 35, right?
The answer.
So answer. This command, this style of command, line 34 and 35, will be used again and again in our project. So originally answer was equal to just rectangular brackets with empty. Now you see that it expands over 2 lines. It means it will be an array of increasing lengths. So each time we come through this part, the length of array will increase, and we save good value of K that matches boundary condition into the array A. So you write what you like. I try. Oh, yes, array of increasing lengths. Good. I will just copy paste an array of increasing length. Good. I'm just learning how to pronounce length. In fact, it's length. If one reads every letter. Now, and one saves the good value of frequency that matches boundary conditions. Boundary conditions. Very, very good. very good.
What goes in between of increasing lengths and good value of day?
Now, and so this and means stop conditional commands related to good values of k. So all commands between if and and are corresponding to this good value of k that matches conditions. After the end, we'll go to regular things. Okay. So line 38. What is this? So sum. Who is reporting differentiation and integration on Monday? Does anyone has power? Not you. Okay. Eva? Oh, maybe Sam. He's the first. Who is the second? Just
Yeah, Sam's first.
okay. So Sam, do you do integration differentiation?
I believe so. I think I do integration.
I do vectors and matrices.
Okay.
Because I think I do all the math. I think that's what I do.
Yeah. So I think this line 38 is integral, right? So it's like integration of good wave function from 0 to inside the box. So integrate the good wave function inside the box. I don't know why I added here, because for pure normalization, one would need to integrate wave function squared. Maybe it was just a byproduct. Okay, how many lines do we have?
Matrix and plus button, and now the key commands are not working correctly. Press the bottom left button that has like the globe on it.
Did you erase anything?
No, but I think I accidentally switched it to like a Russian keyboard.
At the top, you can just put mouse and click on it, and there will be US keyboard. Or you can typing in foreign language.
I don't know any Russian.
If the rest of the class doesn't know as well, you can pretend, oh yeah, I know.
Oh, yeah.
Catch me if you can. Okay. Okay. So norm.
Somebody told me once I have the voice for German. I'm not sure if that was a compliment or not. So.
Not yours. Okay, so norm integrate the good wave function inside the box. Okay, I think we need to leave a little of space for Eva and Fred. So your watch is complete.
I already went up for it.
What did you watch the Game of Thrones?
No, I haven't watched any Game of Thrones. No.
Any of you?
I did.
Oh, did it? Fred, did you?
Sort of.
Maybe Sam did. What? How did they tell when the night watch, when they are done? When someone is killed from night watch, what they kill? His watch is complete. His watch is ended.
He's picked his last talk.
Huh? The watch is over. Okay.
Oh, yeah.
Oh, why I'm going here?
Oh.
You are starting your watch. Oh, and probably you like camera focused on you, right? Why not? Okay, let's type. Which line are we focusing at? 40. Oh, I missed Eva.
Yeah, you.
Okay, good. I apologize. Okay, line 40. So in what is interesting? If someone is speaking, it means I need to take interview.
Yeah, that's what you're talking about there.
Yeah.
Asking about how
No,
on
you
your
don't.
Mac, you could like just
On-
tap the track
Yeah,
pad.
you can go like that. You can just like tap it to select stuff. I actually have to like physically click it.
Yeah, so go to trackpad.
Definitely.
I'm very embarrassed.
Have to click.
So the question that we need to discover right now, what is the meaning of variable I? And it is not defined before, so let's, what is I? I know that your watch is over, but can you help us?
What is I?
Yeah, what is I?
Ooh,
Besides the imaginary number
No, I is,
as
Double
a
I.
variable? Oh,
Yeah.
I.
so,
well, I squared is -1, right?
but variable I.
Oh,
Here. So I think the variable I will be counting. So since we have different number of grid points and solutions, we need to count them independently, something like this. So the variable ck at array ck for the element number I is how good the criterion is met for the trial function of the number I and frequency and frequency k. Do not worry, it will be typed on your screen and frequency k. Then I cannot pronounce it. Kk of I equals k. So the value of frequency for the trial function, trial function number I is stored into this array. Okay. Now line 40 axis. So you see it is not very complicated, but a little unusual compared to what we did before. So it has two types of brackets, angular and rectangular, right? So first angular and inside is rectangular. And we do have 4 numbers, right? So first we are setting the ranges of x and y variable for the image. Setting x and y ranges of the variables for this plot. And I increase adding one more line and telling first 2 numbers tell minimal and maximal values of x on the screen. So it means x will start at -1/4 of L and end at 5/4 of L. Second, 2 numbers correspond to minimal and maximal values of y on the screen. So if you look on the image, on the y-axis, it goes from minus 1.1 to 1 to plus 1.1, right? Then line 45, X label position, you just label the axis. Label the axis. X axis. Next line, label Y axis. Okay, do we have enough? Yeah, let's. Okay, yeah, one more line for Fred, and then you. So I think this command plots the black rectangular. Plot the black rectangular. Okay, and pause means just wait for a human. Or a human. Okay.
Oh, we left so much for Ava.
You did like that same amount. What are you talking about? Don't even give me that, friend.
Once I get used to it.
Okay.
Yeah.
So this rectangular brackets means to bring interesting variables to the print to the screen. Print 3 variables at once. Print 3 variables at once. Line 51, increment counter of waves. Increment counter of waves. Counting variable counter. And means end the cycle. So repeating procedures will repeat only above this end. After end, it will be just linear. So end of the cycle over frequencies equal MCS. Lines above this will repeat, lines below will not. Lines above this will repeat. Lines below will not. Lines below will not. Wait for human. Figure. Figure means open new box, new frame for figure. Open new frame for a figure. Plot KK, CK. What do we plot? Plot tolerance. Tolerance. No, not tolerance. What a degree of matching the boundary conditions as a function of frequency of the wave. Okay. G0 is K. Just a straight line equals 0. Line parallel to x-axis. Plot KKG plus tolerance. Plot I don't know how to express it. So the last image that, well, pre-last image is showing degree of matching boundary conditions as function of frequency. And now we need to add lines that set up tolerance if this degree matching the tolerance. Or if this degree matches just the preassigned tolerance. So I don't know how to make a grammatically correct sentence, but here the x-axis is values of frequencies, right? And y-axis will be how far the criterion of matching boundary condition is from zero. If it is close to zero or it is far from zero, and we put just ranges. So our criterion needs to be within ranges. So we plot red ranges of matching boundary conditions. Better? No? I type just grammatically incorrect. If this degree matches the preassigned tolerance. Okay, yep, that's great, thank you. So next two lines, we are almost done, right? So just label axis, label the x-axis, label the y-axis, figure new frame. And here we do plot x-axis is frequency divided by pi. So it is expected to be integer number n from the solution. If you can express it better, please go ahead. I'm expressing it not elegantly. So before we used x-axis, the frequency, now we frequency divided by pi, and it is what is on the blackboard. Alpha equals pi n. If you do alpha divided by pi, then it will be new variable, which will give solutions when it is exactly integer numbers. And the y-axis is inverse of the tolerance criterion when the criterion is 0. This function has function 1 has maxima, because there are several of them. Okay, that's it. Okay, yep, many thanks. So let's check
That's nice.
file safe.
I'll vote that.
What
So-
does line 69 say towards the right side? Oh, is 0 the function? Okay.
I'm not confident in my spelling, but I would try to be criterion.
Yeah, that's probably right.
Okay.
Yeah, just my spelling.
Okay, I got it. Thank you.
Currently known for it.
Okay. So
This got fired. It's fine, it's not my desk. So. No.
so I believe that this last figure that Eva did describe should be convincing. So when this function has sharp peaks, it indicates which values of n are allowed for this arbitrary function to match the boundary conditions, right? Okay, so please create a brief, very brief couple of slides PowerPoint with screenshots of these figures that you find reasonable, and send it to me as an email with your commented